nice to get at Claremont, isn't it, Dylan?
Yeah, absolutely. Right when finals are ending and everything like that, it's nice to have one more day just to de-stress.
Yeah, definitely. It's pretty incredible out here. It's so beautiful, the rock formations and everything.
Yeah, I can't even believe these rock formations. Do you know how they got like this?
Well, actually, the rock formations here in Joshua Tree were formed over 100 million years ago when convection heating sent molten rock oozing up through the Earth's surface. The specific type of rock here in Joshua Tree, this stuff here, is actually called Monzo granite.
The Monzo granite developed a system of rectangular joints. One set, oriented roughly horizontally, resulted from the removal by erosion of the miles of overlaying rock, called gneiss. Another set of joints is oriented vertically, roughly paralleling the contact of the Monzo granite with its surrounding rocks. The third set is also vertical, but cuts the second set at high angles. The resulting system of joints tended to develop rectangular blocks. As groundwater percolated down through the Monzo granite's joint fractures, it began to transform some hard rock mineral grains along its path into soft clay, while it loosened and freed grains resistant to solution. Rectangular stones slowly weathered to spheres of hard rock surrounded by soft clay containing loose mineral grains. Imagine holding an ice cube under the faucet. The cube rounds away at the corners at first because that's the part most exposed to the force of water. A similar thing happened, but over millions of years, on a grand scale and during a much wetter climate.
Wow, that's so interesting. There are 3 basic aspects of Earth's geology that are important to the study of life in the universe. The first is volcanism.
Volcanoes are essentially holes in the Earth's crust. Volcanoes are generally found where tectonic plates are diverging or converging. The Mid-Atlantic Ridge is an example of volcanoes formed by diverging tectonic plates pulling apart. Most volcanoes found in the Pacific Ring of Fire, however, are volcanoes caused by convergent tectonic plates coming together. Volcanoes are also formed at hotspots in the Earth's crust, where the mantle is close to the crust. On one of these hotspots, the islands of Hawaii have formed. Volcanoes have also been found on other planets. Cryovolcanoes, or volcanoes that spew ice rather than lava, have been found on some of the moons surrounding Jupiter, Saturn, and Neptune. Volcanoes are also vital in the formation of new rocks. When volcanoes erupt, they spew magma, which is essentially liquid rock. It is only when magma cools that new igneous rock is formed. Volcanoes are a key part of the Earth's geological cycle.
The second one is Earth's magnetic field.
The Earth's magnetic field is mostly caused by electrical currents in the liquid outer core, which is composed of molten iron. The magnetic field protects the Earth's atmosphere from solar wind, a stream of energetic particles emitting from the sun. These particles would strip away the ozone layer, which protects the Earth from harmful ultraviolet rays. It is thought that Mars lost all of its atmosphere once the strength of its magnetic field was depleted. The polarity of the Earth's magnetic field is recorded in igneous rock. Changes in the magnetic field are depicted as stripes centered around mid-oceanic ridges where the seafloor is spreading. These stripes can be used to date different types of rocks.
And the final one is plate tectonics.
The Earth's crust is divided into 8 major tectonic plates. The direction in which they are moving determines the types of geological features found around plate boundaries. There are 3 types of plate boundaries that define geological features. The first 2 are divergent and convergent plate boundaries, which form geological features such as volcanoes, while transformation boundaries are found where 2 tectonic plates are moving side to side and are more prone to earthquakes. These plates can move anywhere from 10 millimeters a year to 160 millimeters a year. The movement of plates has allowed rock on the Earth's surface to recycle itself.
So Dylan, what's the most fascinating part of the study of geology for you?
Well, Gabe, for me, I would say the most interesting thing is radiometric dating. This is the process of dating rocks based on the half-life of carbon. So, Gabe, what's the most fascinating part of the study of geology for you?
Well, Dylan, for me, the most fascinating part of geology is that in all of our explorations, the Earth is the only planet that we found that has continuing plate tectonics.
Fascinating.